For the session 2 of day 5 on our FDP on 5G networks, technologies, application and research perspectives. Today, we are privileged to have Mr. Amardeep Singh, Product Manager at ATAL Universal Systems, the deemed OEM of OptiWave, as our esteemed resource person. Mr. Singh brings over 15 years of rich industry experience in the field of photonics, optical communication, and design automation. Throughout his career, he has been actively involved in providing advanced photonic design and simulation solutions to prestigious organizations such as IITs, NITs, DRDO, ISRO, BEL, and L&T. His expertise spans optical communication networks, photonics, nanotechnology, free space optical communication with significant experience in atmospheric channel modeling, turbulence analysis, and PAT system integration. He has also contributed to prestigious projects with SAC ISRO Ahmedabad, DRDO Laboratories, BEL, ADA Bangalore, and the Central Vista project with L&T. He is also a certified professional in cadence, OptiWave, RHCE, RHCI, and RHSS. Today, he will deliver a session on design and performance analysis of DWDM based 5G optical network using OptiSystem. This topic is highly relevant in the era of high speed optical communication and next generation 5G networks. And I'm sure his practical insights will greatly influence all the participants. Please join me in extending a warm welcome to Mr. Amardeep with a huge round of applause.
Thank you. Thank you. Thank you. Thank you.
Now I would like to request Professor Kirti Gupta ma'am to please present token of appreciation to sir. Thank you, sir, for taking your prestigious time for us.
Thank you. Thank you so much for the honor.
Now I request sir to please carry on the session. Thank you.
Thank you so much for this warm welcome. And let us start with something new. I do hope you all must be aware of such kind of applications. If not, then we will discuss further. And in case you have any technical questions, queries, so definitely you can reach me. And later on, in case you want to interact, you can have my details and our company details as well, so that we can proceed further for any kind of your queries. So let us start. And before we proceed, I just want to know from everyone, like, who knows well about optical communications or photonics, or if you have studied, anybody? Yeah, basics, everyone knows about that. Okay, so from the name optical, so would like to interact with you. What is optical communication? I always start with this question. Partially it is fine. What is optical communication? Yes, correct. As a layman, anything you want to transfer or communicate with the speed of light is optical communication. So, if you modulate it, if you modulate the data, bind that as a carrier on a, exactly, no, basically when you transmit something and the carrier is laser, so that is optical until it is received. No, it is also not necessary. Optical fiber is not necessary. It is one of the medium. It is one of the channel. Exactly. So can you give an example of microwave application, which you can also state that it is a optical? Yes, that is a modulation technique. You're correct. You're correct. Whereas in case of normal optical communication, as a definition, I was just explaining that whatever you want to transmit at a speed of light, that is optical communication. But still, optical fiber is just a medium. I think that is a good starting, because no, no. See, it's good to interact and then to proceed further, because uh, I also want that we will interact in a better way, and then we can clarify all the information we have, either you have or either me have. Anyways, in between, sir was mentioning optical fiber. So optical fiber is one of the medium where we say optical fiber communication. But if we segregate it into types, then instead of fiber, you can also choose optical wireless channel or a medium. So that is known as free space optics. Right now, the utility of FSO, that is free space optics, is in huge demand, because it will be a expensive affair if you continuously use SMF, single mode fiber, because maintenance cost is high. So instead of utilizing single mode fiber or multi mode fibers as per your applications, you can replace it with FSO, that is a telescopic connectivity. Means at a transmission side you have a transmitter telescope, and at a receiver side you have a telescopic receiver. In between, no medium, nothing, it's only air. So that is free space optics. So the range and the communication media also depends upon attenuation factors. We will proceed later on that, because atmospheric conditions, in case of attenuation, whether it is due to heavy rain, fog, clouds, or hazy environment, you need to establish FSO based communication by playing with beam correlation, beam width, right, of the telescope, and as well as taking into account the attenuation part. So we will proceed further. Uh, so first of all, generic information about us, what we are and what we do. So we established in 1994, Ottawa, Ontario, started with the optical spice-based simulation tools, then beam propagation tools, and later on we got indulged in system-based activities, means optical communication system-based activities, and HR Universal Systems. Us are the channel partner or a system concern company of OptiWave Canada, and we are established in India. So, in other words, our duty is to customize the requirements of commercial sector in India for their own kind of devices or products like PICs, or you can say any kind of communication based setups. So we design for them like DRDOs or ISRO, and they pay us and we provide the same to them uh, with some MOUs or with some project timelines. Within that project timelines, we do that. And this simulation tool basically very similar to every other simulation tool available at your institute or available worldwide, because the basic scenario will always remain the same before you actually start implementing the same through equipment. You need to simulate that so that at least you are well versed or well advanced, like full-fledgedly you have the knowledge that you will be proceeding with the project implementation, so that you can check the simulation parameters and accordingly you proceed further for the implementation part. So in this way the product quality can be improved, and definitely it will be cost effective. So these are the product lines we have. So that is very important for you to understand in case you want to know about a complete photonic designing. So whenever you hear about photonic designing or optical communication, then we can segregate the same application wise scenarios into these platforms. For the system level, we have opti system, where you already have available set of components like transmitters, channels and receivers. Apart from that, you have the availability of visualizers. For example, in your labs you have oscilloscope analyzer, you have power meter, function generator, or you name any equipment which you have in your lab. So in that regard, we have the visualizers so that you can connect it across the components on OptiSystem layout platform, and you can check where your signal is representing what. So you can see that. And I think if you have ever gone through OrCAD PSpice or Mentor graphics tools, Cadence, VLSI, Virtuoso as well. So these are some of the renowned software tools. So similarly, the backbone will always remain the same, like simulation engines, so that you can avail the component designing methodology. You can study about the relevance of your application depending upon the components you utilize inside OptiSystem platform. So we will again move forward with the software scenario. I will use it. Then OptiSpice. So OptiSpice is also similar to the tools you have like uh, Cadence, OrCAD, PSpice maybe. So there you have the set of EDA components, electronic design automation based components. So you have thousands of components available there. So in this case, this covers two engines. One is optical, one is electrical. So that is the reason we call it as a optoelectronic circuit simulation tool. So in case you want to design any kind of a laser device, or you can say LED or LED driver, or any optical based modulator, absorption based modulators, then you can design it in OptiSpice, and later on, once you are satisfied with the output of that device in OptiSpice, you can interface it inside OptiSystem, so that at least you can see how that device is behaving inside a communication environment. I hope it is clear. In case you have any query, you can ask or we can interact similarly. Then we have component level, that is Opti BPM. So BPM, let me explain you like beam propagation method. Now we are moving towards physics. So beam propagation method will allow you to inject laser source into a structure. For example, this is a structure, or even my body, anything. You have a structure. So if you inject a light, how that structure will behave, what are the properties you may have, its spectrum, its absorption, scattering, DFFT, FFT, uh, then you have leaky current, then you have pixel methodology. Pixel methodology means within a structure you can zoom in pixel by pixel and see the mesh of that pixel area, and you can also analyze in that structure at what extent at what intensity the light is injecting inside that area. So that is basically a beam propagation method, and with the help of this beam propagation method, all your passive components like uh, interferometers, Mach Zehnder modulator, and optical power combiner, optical power splitter. So these kind of components or applications can be performed using OptiBPM, using beam propagation method. And the background at which it works is Maxwell's equations. So that was for BPM, for single direction. And if we want to do it for unidirectional, and uh, if we focus on the size, for example, you want to study about the characteristics of a nano gold sphere or a silver sphere or a combination of any doped material, silicon, arsenide, germanium oxide, such kind of doped material based application or devices can be performed using opti FDDT, that is finite difference time domain. So that is also part of physics, whereas when we use wave sources like continuous wave sources or Lorentz Drude based uh, sources, then this comes into picture, that is finite difference time domain. And recently, like if I want to define as a case study, ISM Dhanbad, that is IIT now, IIT Dhanbad. So they are getting a lot of projects from uh, Jharkhand government related to coal mines, right? So they are getting some you can say sort of subjects related to coal material, and then they used to experiment on that on the basis of beam propagation method and finite time difference domain method. So they perform experiments utilizing these because it gives you a platform where you can define a structure, define a property of a material there, and then you can see how the laser source or any kind of injection with that structure defines or create the properties of various applications. So I'm not sure if it is clear to you. So this is our one of the tool related to component level design. Then we have Opti mode, any kind of modal analysis. Modal analysis means you want to see the cross section of an optical fiber and want to, yes, opti system में exactly. Good question. You need to have a net list of that program. Net list programming. That's it. Uh, it's not mandatory to have that .sp, but we need the content as a program netlist of a spice language. That's it. Any software you can utilize for that. Copy paste. But in case sometimes what happens, it requires some of the local host integration. Local host integration means, for example, using netlist, I am calling some component, right? And the syntax of that component is not relevant to from where you are exporting that. It will be relevant to the Spice language only. But your the component syntax should be taken from OptiSpice library only. That adjustment you have to maintain. Otherwise, it is same. Okay. Okay. You just create a netlist of a Spice language for that models. For example, if you have a Spice model in Orchid Spice, just an example, or a mentor graphics. So there you have a availability or a platform there where you can create a netlist of the model. There is a facility there. So whatever the circuit you have designed for that model, you can. Mhm. नहीं वो नहीं होगा, दैट इज नॉट पॉसिबल बट इसके लिए एक बहुत सिंपल सरल तरीका है, वो ये है कि यू कैन यूज पाइथन। आपका जो भी मॉडल स्पाइस का है, नहीं आप कमांड, मैं वही बता रहा हूँ, पाइथन सी प्लस प्लस मैटलैब, यू कैन इंटीग्रेट जो भी आपका मॉडल है, यू कन्वर्ट दैट मॉडल इनटू एनी दीज ऑफ प्रोग्रामिंग लैंग्वेजेस। पाइथन पाइथन इज आई थिंक बेस्ट, क्योंकि वर्ल्ड वाइड यू कैन गेट अ लॉट ऑफ हेल्प फॉर डिफाइनिंग योर ओन मॉडल इनटू पाइथन लैंग्वेज। तो पाइथन इज फ्री वेयर मैम। ऑप्टिस स्पाइस नहीं है तो मैं आपको इवेल्यूशन दे दूंगा मिस्टर वरुण। वी कैन गिव देम इवेल्यूशन फॉर 3 months at least, so that they can just start with, हो जाएगा for sure. 10 users. No. HDL के लिए we were doing that, but response was very less. We were doing LDEC earlier, but not now. Python is like solution for everything. For example, you have Opti system with you in your labs. So you want some model from Opti Spice or any Spice model you want. आपका कोई भी सॉफ्टवेयर है, उसकी नेटलिस्ट को you just give it to some AI, convert it into Python, and after that you use that Python. But as it is, आप use नहीं कर सकते. We have some own syntax for Python. She knows very well. So we can do it in Python, and then we can interface it in OptiSystem. Very well, you can do that. Okay, that's a good interaction. Anybody, any query? Okay, let us move forward then. Opti mode. So I was at Opti mode. Any kind of a modal analysis. See, these all kind of analysis I am dictating right now will be very useful for you in case if you have like students here. If in case you grabbed in some manufacturing industry or in DRD or in ISRO, so they utilize it very well. All these kind of analysis. So in case you want to do a modal analysis of a like cross section of a fiber or a multi-mode fiber or a multi-core fiber, all kind of parameters in association with these applications can be performed using OptiMode. And this is also a packaged tool inside FDDT and BPM as well. So it's a kind of a analysis environment very similar to FEM, ADI, ANSO. So these are some of the modeling techniques to model or study a structure when it comes into picture with the injection of the current. Depending upon which kind of laser source you are using, either it is a CW laser like continuous wave laser source or a Lorentz Roots model or any kind of a, you can say, suppressed Gaussian wave. So these are some of the formats which can be utilized for your model analysis in the application formats. Then we have OptiFiber. So this is very generic tool to customize your own optical fiber. In India, Sterlite Limited, ATAL, HFCL, Paramount. So these are some of the big players in India, those who are fabricating optical fibers. So they are utilizing OptiFiber for their R&D purpose. So before proceeding with the fabrication, they compile a whole fiber profile which consists of every information related to fiber like core, cladding, its material, then birefringes, PMD, reflection, transmission. So all these parameters are associated with the component that is fiber and can be designed using OptiFiber. Then we have OptiGrating. So this is also a good tool to study or to make your own fiber Bragg grating based sensors, or you can say optical fiber Bragg grating based sensors. So in India, uh, yes and no, both, because grating will help you to design a sensor or a you can say a grating component or a grating based device. No, optic grating is consisting of the you can say blank blank parameters like Selmier equations, where you need to put on the parametric values. For example, you need to define, first of all, you need to define core and cladding. Then you need to define the length of the grating, like it is 1 meter, 2 meter, 0.1 meter, the size of the sensor or the actual hardware you will be compiling. And then once you have the waveguide structure of that grating, then you start putting, or you can say the start playing with the parameters like stress, strain, right, and wavelength, then azimuthal angles, Selmer equations. So these are some of the parameters which you need to feed in as per the Selmer equations. Once this whole setup is ready, you continue with the simulation part where the output will be shown in the form of exactly. No, no, you are manually designing the sensor, but whereas that toggle will automatically guide you. Yes, yes. Optigrade, exactly. So once you are that, within OptiSpice, you can use your designed parameters of OptiGrating, but within grating you cannot use OptiSpice because OptiGrating के अंदर तो there is no such use. Spice के अंदर use हो सकता है for you can say sensing application or Bragg grating based applications. Bragg grating क्या होता है? It's just uh, a format where you can choose which wavelength needs to be back reflected, right? So उस केस में you can utilize OptiSpice and use OptiGrating design inside OptiSpice. OptiSpice ग्रेटिंग का नेटलिस्ट नहीं होगा. नेटलिस्ट when we talk about हाँ यस ही इज राइट. ये और भी डिटेल में अच्छा एक्सप्लेन किया मैंने. optical fiber can also be used as a sensor. Right. Right. So, in India, under Department of Atomic Energy, there is RR CAT. CAT इंदौर बोलते हैं उसको. That is a government organization. So they have the fabrication facility for fiber brag ratings, and also they are fabricating these FBGs for Indian Railways. Indian Railways की application में they require FBGs to back reflect the signals which they do not require. So in that case, they are fabricating for them. So they are utilizing optic grating for their R&D purpose. Then we have Opti Omega. So since everybody, I hope everyone belongs from electronics, communication or telecommunication. So I think Opti Omega will also help you out in case you want to proceed further with PIC designing, photonic integrated circuits. So right now there is a huge demand of PIC based collaborations, especially if I talk about CDAC Pune and ISRO Ahmedabad, LRDE Bangalore, and DLRL Hyderabad. So these are some of the you can say the main organizations. DRDO, everyone understands what they do. So they are looking for the collaborations related to PICs, and they are also buying this Opti Omega because this will give you a platform where you can take care of the PIC interface of circuits using OptiSpice, and the circuits will be overlapped on a waveguide, that is FDDT, and its simulation will be done using a GPU, not CPU. GPU will help you to fast process the whole simulation environment, because uh, again, sorry, again, if I want to simulate this effectively in FDDT, it will take around 8 hours if I use CPU, and if I use GPU, graphic processing unit, then it will do the same in half an hour. And all these methodologies are taken care by Opti Omega, because this platform gives you Python environment where you can design your circuits inside OptiSpice. You can choose the structure where that circuit will be overlapped using Opti FDDT, and with the combination of that, you can get ready with a PIC. And later on, recently we have added one new product into our list, that is Lucida. Now we are the channel partner of Lucida Photonics in Belgium, because they provide you a platform where you can reach up to PDK level, so that will be a foundry ready product and you can get it fabricated. So all these facilities are directly not available in India. So that is the reason all these organizations which I was explaining to you want collaborations with the institutions, especially those who have such kind of simulation platforms along with the expertise. So later on, in case if you have any plan, we can proceed with the collaborations. Now, at last, Opti instrument, that is instrumentation level. So any kind of simulation environment you want to integrate with your hardware available in your lab. For example, oscilloscope, function generator, uh, power source, optimizer. So any kind of a component you have in your lab which gives you a data log or have the capability to connect with your system, you just need to fetch the output from that equipment, give that output to Opti instrument, and utilize the same output inside Opti system. Means that will be two-way successful simulation. You have actual hardware values, and the same hardware values you can utilize inside your simulation. And a lot of PhD scholars are utilizing this method, because I think in PhD there is a scenario where you have to show both simultaneously. simulations as well as practical implementation. So they integrate, they make a hybrid system so that it will be easy for them to get passing marks. Okay, anyways, so this all whatever I have explained to you is known as photonic design. So if somebody asks you what is photonic designing, you start with system level. In system level, we already have components available. You only analyze it. Component level, you design your own component and use in system level. And at last, the combination of both, that is hybrid, your hardware as well as software. So this complete setup is OptiSuite as per our language, because this is our product. But generic way, you can as per the phenomena, it is photonic designing and simulation environment. Any question? Okay, let us proceed further. Anyways, you can also read it from our website. We have this, and lot of corporations, universities, government organizations we have. Our partial list of worldwide customers, we are getting a lot of money from them basically. Yes, the license you have is perpetual. Otherwise, we also deal in cloud-based or term-based license, depending on project to project. Cloud means you can access the software using licensing connected through internet. अभी जो मैं लाइसेंस अपने सिस्टम में यूज कर रहा हूँ, yes, there is a lot of encryption and it is taken care by Thales. Flex ILM was like getting very old. Now it is taken care by Thales, USA. Okay. Now coming to the subject which for which we are here right now. For the solution for what? Dense wavelength division multiplexing, that is DWDM. You can multiplex more, means it is not restricted to use only 4 channel, 8 channel, 16, 32, 64. You can like go beyond n. That is not possible, sorry. But anyways, you can program it using Python, like for the number of channels. Otherwise, you have the availability where you can have maximum number of channels, right? For high capacity, efficient results that can be scalable and which will be future ready for your own applications. So here, what is DWDM? Anybody? Sir? Okay. Exactly. Exactly. Yes. You're asking me? Okay, okay, okay. Channel spacing, you already answered. Let me come back to you. From? Exactly. Uh, हम 1550 एनएम भी बोलते हैं उसको, 1550 एनएम भी बोलते हैं. फॉर एग्जांपल एनएम 193 टेराहर्ट्ज जिस पे एटेन्यूएशन और डिफ्लेक्शन डिफरेंट. एग्जैक्टली 1550 पे मिनिमम है और उस पे एटेन्यूएशन और डिफ्लेक्शन Okay, let me explain. First of all, let us start with the WDM, wavelength division multiplexing. For example, you got the subscription from Tata or Reliance for this institute for utilizing your internet activities. Not only internet, your landline phones, the ATMs installed, or you can say 4 to 5 applications: internet, your broadband connectivity, your landline phone, and whatever the other subscriptions you have through the same vendor. So what that vendor will do, that vendor will give you a optical fiber. For example, that fiber consists of multiple cores: 2 core, 4 core, 6 core, 96, or even more than that. Depending upon your utility, for example, if you have only 4 utilities in your campus, he will give you a 4 core fiber subscription, where that fiber ends at the terminal box in your institute, and from that terminal box at various lengths, or you can say various frequencies, or you can say various wavelengths, that subscription can be extended to. You can say that. You can say that. The terminology is right, but the way of the application and the methodology is different. Because in WDM, what we do is, using the same fiber, we use demultiplexer for various wavelengths or various frequencies again, right? So that various frequencies or various wavelengths can be distributed or demultiplexed for different channels, say 16 channels. Then the same data or the signal will be operated utilizing a fiber or a free space optics without a fiber. At the other end, you can receive that data and mux it using a muxer, right? Demux we already have done. This is this after fiber. When see we mux मक्स कर लिया, यहाँ पे अलग अलग सारी की सारी, वो एक आउटपुट आ गया आपके पास. Then the one output can be utilized using a optical fiber or a free space channel. After that, you need to split that using a demux or a power splitter. Not necessary you use only a demux, you can also use a power splitter. Now here comes a question. In optical, we use this methodology where muxing and demuxing is not important, where in this case it is the combining the power and splitting the power is important. Then when you split it, the channels can be again categorized into various frequencies or wavelengths. Now this is your frequencies or wavelength. WDM is different from FDM. Wavelength division multiplexing. It's just a change of names. Sorry. Okay. Okay. 5 minutes. 5 minutes, huh? Okay, so basically we were talking about DWDM and applications. So in other words, you can multiplex more and get the more efficient output data using DWDM. Acha, okay. So we'll wrap it up, no issues. Then we have a layout design for DWDM. So in case you are interested, you may be having installed OptiSystem softwares. So you can go through the scenario where we have a laser source, then a polarization splitter. Here polarization matters, and then we are modulating it with external data in any format, NRZ, RZ, then passing through free space optics channel, not fiber. You can also use fiber, but I want to use FSO here. Then again polarization splitter, where you can see the various special modes you are getting for an optical signal. And at last, you can again, with the same scenario, you can find it out for Q factor, BER analysis, SNR. Hmm. Right, right. There is a huge difference between a splitter and a fork. Fork, fork will always be used to copy. To couple. Coupler usually act as a switch. Usually act as a switch where, as per the logic of that coupler, whether it is a star coupler or any tree coupler or any coupler you are using. So according to the logic, if it is 0, it will go to this output. If it is 1, that will go to that output. Okay, next. And this is important. I just need your focus for a minute's time, not more than that. In case you in case you want to integrate everything, high capacity transmission DWDM से use कर लो. Then for the transmission, you need to secure the communication. You can use QKD. And then for the QKD part, in case you want whole transmission in a free space optic environment, you can use FSO. And for FSO specifically, if you want to move your data randomly utilizing a random moving object, you can use UAV. And at last, if you want to bind it with LIDAR, light detection and ranging system, again you can bind it with the LIDAR. So in original or actual situation, it will be a very complex situation for designing this as a hybrid simulation system. But in case you get success, then it will be a different scenario, because nobody till now has done this kind of simulation based application environment scenario. So let me read it out, then afterwards we can go for a tea break, right? So you multiplex multiple wavelengths to transmit terabits of data over a single optical fiber who has massive bandwidth, cost effective capacity for the scaling part, and that is a backbone of 5G, 6G or even more renowned applications. That is in relation to DWDM. And whatever the communication you are performing here, in case you want to integrate it with protocol based or cryptographic based communication applications, then you can introduce QKD, quantum key distribution. You can use a protocol, for example BB84. I'm not sure if everyone knows about BB84, but let me tell you, BB84 was the technique or the application or the protocol of cryptography or a cryptographic technique founded by Bennett and Brassard, so that whatever you are communicating with respect to the photon entanglement can made secure. So After using this quantum mechanics or cryptographic technique, you can use a medium that is free space optics, where you can define your weather conditions, your attenuations, your scintillation proportionalities like gamma gamma malaga with respect to height of the transmitter or receiver you are utilizing. And again, if you want to make it more flexible, you want your medium should be flying here and there. So in that case, you use UAV communication channel. It help you to maintain the beam wanderer basically. So beam wanderer is basically the concept where the beam from a transmitter should be proportionate to the flying object. That beam, I do hope everybody knows about beam. So the beam, its focus or its acquisition or tracking, and completely if I frame it, pointing acquisition tracking PAT system, then beam wanderer is important. And in case you want to stable that, you can use UAV channel which is available in OptiSystem. And later on, the same can be extended to detection and ranging, light detection and ranging, that is lidar. And at the end, everybody knows you have to receive it using a pin photodiode, and then you can analyze it using whatever the visualizers you have. I hope somewhat it is clear. Any question? Anybody? So in general, you have a more capacity of a data, or a, you can say, bandwidths you have, which also includes more security. Then more connectivity means you can segregate that, you can split that into multiple FSO systems. And multiple FSO systems again can have their own UAVs. For example, within your campus, it is like 6 acres or 7 acres maybe. So within that range, every building can have their own flying drones which are carrying high capacity data using DWDM. And at last, your UAVs again can be further connected with the vehicles in your campus, the vehicles parked or moving around your campus for lidar system. And at last, you can see how the whole system is behaving. So this is a kind of a conceptualization which 4 to 5 organizations are already working on, but they have not got success. They are trying, and definitely we are also working with them to get it fabricated for everything. Anyways, I hope this seems interesting for you, because this is a kind of application which nobody do, but we are doing. Thank you, and I think we can have a tea break. Anybody? इनपुट किस तरह का? हम्म हम्म फॉर एग्जांपल आपका HDL उसका आउटपुट क्या होता है? बिट्स. यू कैन यूज द बिट्स इनसाइड ऑप्टिक सिस्टम. उसमें एक ये सारा का सारा बिट्स पे ही काम हो रहा है, जितना भी है इंक्रिप्शन बेस्ड है. सो यू ऑलवेज मॉड्यूलेट डाटा इन द फॉर्म्स ऑफ बिट्स. आप साउंड एनवायरनमेंट है कोई भी है, FPGA इनपुट क्या लेता है? द टाइप ऑफ सिग्नल, इलेक्ट्रिकल, ऑप्टिकल, बाइनरी, एम एरे, ये चार तरह के सिग्नल इट इज़ वेरी कॉमन इन द सिमुलेशन प्लेटफॉर्म्स, ऑप्टिकल, इलेक्ट्रिकल, बाइनरी एंड एम एरे. हाँ हो जाएगा. बिट्स हो जाएंगे जनरेट. द डाटा कैन बी रिकवर्ड एट द रिसीवर एंड इन द फॉर्म ऑफ बिट्स. अगर आपका जो एनवायरनमेंट है सॉफ्टवेयर एनवायरनमेंट, इफ इट टेक्स डिजिटल बिट्स जीरोज एंड वंस, तो इसमें ये फैसिलिटी है कि इसका जो आउटपुट है एट द एंड यू कैन रिकवर द डाटा. इसमें एक डाटा रिकवरी टूल है कंपोनेंट which can be utilized after receiver, that is pin photodiode. So once that data is recovered at pin photodiode, you can collect or record the data in the form of bits, text, text format, text, dot txt. Yes, you can use that data. It was a nice interaction. Yes. फिर आगे बढ़े. ओके ठीक है, डन. ओके लेट अस मूव फर्दर बिकॉज अभी चाय बन रही है. अच्छा, निखिल knows that. Sorry. Yes, yes, yes. Recently we have developed a new component that is satellite FSO. You can use that. You can talk to Parshuram sir related to the evaluation. Sir, you can provide them the evaluation at least just to start with for 1 month, so that at least they can have an overview.
Model on is Microsoft Edge.
No.
So we can't work with that model.
Microsoft Azure, no. Totally Windows based system. But eventually you can see if you want to create some model which can be utilized using that platform you want, you can use Python then.
So on we using Python.
Yeah, you can use that. Use that.
So it's like to create.
Okay, good. Okay. Methodology is very good, but whereas I am not sure that the ML tool available in the Opti system is that much efficient. I'm not sure because we have started ML in the last version only. But anyways, we can definitely, you can have this one, and you can write an email to me with the description of everything, right? And we can work together. No issues.
So but we can add some processes to this too.
Shortcut?
So like moving the screen and all. We have to do everything with mouse. And in other softwares we have shortcuts to zoom or change the that.
So here you have zoom in and zoom out. Zoom in and zoom out is available.
सब zoom करके and drag करना पड़ता है.
That is a syntax. That is a good method, I think. I have only one answer, that Python will be the best thing for you. But in case you want to integrate before reaching to Python within this operating system, then so here we have under tools, machine learning tool. Okay. So here you can start using your algorithm. So we have this is which version?
Sir, 23.
23.1 is the latest one. Yeah. So you need to install 23.1. I think we have added some more layers of algorithm in ML. Or otherwise, just to start with, you can use this. Or in case you want to have an example, like example is also available for ML.
Feedback in it using that feedback.
I think you can add it. Here is the example under.
So you can use this.
This is a machine learning tool. You worked on. You understood. 1,000 iterations. This is ML. Machine learning means you are training the system, right? So you need to have more and more iterations. So that without maximum iterations, you cannot reach to a proper conclusion. Yes, 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 yes. Because right now in NIT Jaipur, MNIT Jaipur, they are doing same kind of a thing which you are processing right now. And they have huge systems, means supercomputers. They have like 128 GB RAM and all. So they are going to 4 to 5,000 iterations. So in this laptop, I'm not sure. This is a gaming, I think.
Yes, sir.
I do hope this works on that. You can share the flow chart. We will discuss. Uh, I think everyone is waiting for tea. Okay, so you want me to continue or want to go for a break? चलिए मेरे पास कितने बजे तक का टाइम होगा? 5:30 तक. ओके.
Iterations at the बताओ क्या है उसमें अगर हम बहुत सारे नंबर्स ऐड करें तो कैसे ऐड करें
इटरेशन नंबर्स देखिए फॉर दैट काइंड ऑफ ऑपरेशन वर्क यू कैन टॉक टू सर ही इज PhD इन दिस ओनली.
ये आपके नंबर ऑफ पॉइंट्स बढ़े जैसे ग्राफ बनाना आपको 20 पॉइंट्स तो आप 20 इटरेशन ले लो. अब इसमें आपको ग्राफ बनाने को एक पैरामीटर है जो वेरिएबल सेट करना पड़ेगा उसकी रेंज दे दो. सर लाइक मैंने इसमें इटरेशन सेट की थी बट उसके अंदर हर एक इटरेशन की वैल्यू खुद से डालनी पड़ रही थी.
It's not important. You need to see which parameter you want to iterate. For example, length, range.
नेट मैंने इसका ट्यूटोरियल पढ़ा है ट्यूटोरियल 1 ट्यूटोरियल ठीक है मैं एक बार बता दूं फिर सब बता दूं. उसमें जैसे जिस पर्टिकुलर टॉपिक में डाउट है आपको इटरेशन में ग्राफ में 2G में 3G में तो डायरेक्ट सर्च कर लो सिर्फ उतना पोर्शन उस समय देखो. अगर आपके पास कोई आई टूल है तो डाल दो मुझे ये चीज़ है इसे सॉर्ट आउट सेलेक्ट करके तो उस पर्टिकुलर चीज में आपको
I think ये शॉर्टकट ज़्यादा अच्छा है.
करीब करीब 1100 पेजेस का है 1200 पेजेस
Exactly.
वो है आपके सिस्टम का हर चीज. तो जिस पर्टिकुलर इटरेशन में 2G फॉर 3G फॉर जिसमें भी डाउन कॉन्स्टिट्यूशन जो भी लिखना सर्च करो उसका प्रोसेस कर लो उसके हां मैं वो वाला जिसमें मैंने इम्प्लीमेंट किया. अच्छा बोला तो मैंने कॉलम पर दे रखी ना
ये अहमद सर को दे रखी है मेरे ख्याल से आपने, हमें नहीं आई। अच्छा अच्छा अच्छा, ओके ओके
को एक बना के दिया था पूरा एक
ओके
सर्वे बना के दिया था ये सी रैंक आर्किटेक्चर में, इनको बोला था फीडबैक लगाओ, इससे वो काम दिया है इनको यूजिंग एमएल टूल्स, अभी तक नहीं कर पाए। आइटरेशन चैट हो पा रही है तो बल्कि हम सर से डिस्कस करो।
एक काम करना, शॉर्टकट बताता हूँ, बहुत अच्छा शॉर्टकट बताता हूँ। इसके रिलेटेड जो ट्यूटोरियल्स हैं सर ने बताया, उन ट्यूटोरियल को, डू यू हैव अकाउंट ऑन चैट जीपीटी? थोड़ा सा बहुत ज़्यादा शॉर्टकट है ये। वो आपके जितने भी वो 5-6 ट्यूटोरियल्स हैं, मेरे ख्याल 50-60 MB का डाटा होगा, यू अपलोड इट ऑन चैट जीपीटी, आस्क देम यू आर डूइंग दिस एंड वांट टू डू दिस, व्हाट टू डू नाउ, वो एग्जैक्टली दैट इज द बेस्ट वे। इवन आई ऑल्सो यूज टू टेक हेल्प फॉर पाइथन इम्प्लीमेंटेशन, तो बहुत फ़ायदा हो सकता है।
तो जो प्रोफेसर है ना, जैसे उनका वो सीधे होता है, किसी को पूरी फाइल करनी, तो जैसे कुछ यूज होना तो पैरेलल में नेट से सर्च करके
रिसर्चर्स ऐसे ही काम करते हैं।
सारी चीजें।
बताइए।
आपने जैसे इसमें ऑप्टी एफडीपी की बात की और ऑप्टिकल फाइबर की बात की, ऑप्टी और ऑप्टी दोनों लॉस रिलेटेड है, ऑप्टिकल फाइबर लॉस कैलकुलेट करते हैं,
डिस्पर्शन दैट
तो नॉर्मली ये हाफ वेव मॉडल फुल वेव मॉडल में डिवाइड होता है सॉफ्टवेयर। तो मैं उस पॉइंट को इसी जानना चाहता हूँ कि आपका ये जो सॉफ्टवेयर है वो हाफ वेव मॉडल फॉलो कर रहा है या फुल वेव मॉडल फॉलो कर रहा है?
देखिए, अगर तो डिपेंड करता है कि इफ़ यू आर मॉडलिंग सम कंपोनेंट, एफडीटी की बात की आपने अभी,
और ऑप्टी वेव जो आपका
ऑप्टी सिस्टम,
फाइबर की ऑप्टी फाइबर
ऑप्टी सिस्टम, ऑप्टी फाइबर, उसमें जो बेसिक मेथडोलॉजी है दैट इज इक्वेशंस, वो भी बता देता हूँ मैं आपको। मैक्सवेल्स इक्वेशंस सारी की सारी
सारी की सारी
सारी की सारी
सारी की सारी मतलब
होल फिजिक्स, होल होल
फिजिक्स
फिजिक्स रिलेटेड टू द बाउंड्री कंडीशंस टू जस्टिफाई अ स्ट्रक्चर, वहाँ पे बाउंड्री कंडीशंस होती हैं, जैसे पीएमएल, एपीएमएल, वो फिजिक्स में वो डिफाइन करने के लिए रिक्वायर मैक्सवेल इक्वेशंस सो दैट वी कैन सेट अ स्ट्रक्चर। एक स्ट्रक्चर जब सेट हो गया, अब जब हम एक इंजेक्ट करेंगे लेज़र, अब लेज़र किस फॉर्म में इंजेक्ट हो रही है, साइनोसॉइडल, दैट इज अ फॉर्म ऑफ गॉसियन, और सप्रेस्ड गॉसियन, और हाफ वेव सप्रेस्ड गॉसियन, HF हाफ वेव मॉड्यूलेटेड सप्रेस्ड गॉसियन भी यूज कर सकते हैं।
जैसे मैं दूसरे का मीनिंग किया है, अगर हाफ वेव मॉडल है तो उसका जो रिजल्ट होगा फुल वेव मॉडल के कंपैरिजन में ज़्यादा है। फुल वेव मॉडल वो लॉस को तरीके से कैलकुलेट करेगा और एक्यूरेट रिजल्ट होगा।
यहाँ पे जो मॉडल, यहाँ पे जो मॉडल है,
डब्ल्यूडीएम एफडीएम
नहीं वो नहीं, वो क्वेश्चन अलग, वो क्वेश्चन अलग। फुल वेव, ये हमारे जो कॉन्सेप्ट्स है ना, दिस इज बेसिकली फुल वेव, अगर आपके उसमें बात किया जाए, क्योंकि इसमें जो भी मॉडल्स लिए हैं ना, अगर मैं ऑप्टी फाइबर की बात करता हूँ, ऑप्टी फाइबर पे काम करने के लिए हमें कोर एंड क्लैडिंग की जरूरत होती है। कोर एंड, बिल्कुल सही, यही चीज़ है एक्चुअली। उस मटेरियल को डिफाइन करने के लिए जो लाइब्रेरी होती है वो भी है इसमें। अब अगर आप अपना खुद का कोई मटेरियल डिज़ाइन करते हैं XYZ, जो कि वर्ल्ड में अवेलेबल नहीं है, तो आप वो भी बना सकते हो अपना मटेरियल, अपने मटेरियल को।
मेरे हिसाब से फिर ये फुल वेव
एग्जैक्टली,
क्योंकि फुल वेव मॉडल ये हमें फ्लेक्सिबिलिटी देता है
Exactly.
कि हम अपने मटेरियल को इंटरप्रेट कर सकें।
राइट 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 राइट, मैं समझ गया क्वेश्चन आपका।
फ्रीक्वेंसी पॉइंट ऑफ व्यू से उसके रिजल्ट ज़्यादा एक्यूरेट।
अब इसको आप टाइम डोमेन में करो, फ्रीक्वेंसी डोमेन में करो, अब जैसा यूज़ करना चाहते हो उसको कर सकते हो। मैं समझ गया था आपके क्वेश्चन से। इवन हम एक माइक्रोवेव का प्रोजेक्ट कर रहे हैं DLRL के साथ। क्या है कि एक जो आपकी FMW रडार होती है, राइट, ठीक है, उस रडार का रिसीवर हम डिज़ाइन कर रहे हैं DLRL के साथ। इलेक्ट्रॉनिक वारफेयर देखता है वो डिपार्टमेंट। तो एक जब रिसीव होता है हमें डाटा, तो वो जो रडार होगी उसमें हम उसको सिंथेसाइज कैसे करेंगे, वो माइक्रोवेव का काम है सारा, RF इंक्लूडेड, तो वो भी हम कर रहे हैं। तो ऑप्टी सिस्टम आपको एक प्लेटफॉर्म ऐसा देता है, आप माइक्रोवेव, RF, ऑप्टिकल, इलेक्ट्रिकल, सारा कुछ, यू कैन मेक इट हाइब्रिड।
अभी एक बच्चे ने मुझे बताया, मैंने उससे ये पूछा कि जो आजकल हमारे ड्रोन ड्रोन का रेंज फोर्स अभी आपने देखा 2500 किलोमीटर 3000 किलोमीटर तक लेके जा रहा है।
हाँ
तो एक बच्चे ने मुझे ये दिखा था किसी ने कि जो रिमोट होता है और जो ड्रोन है उसमें ऑप्टिकल फाइबर के थ्रू लिंक कनेक्टिविटी जाता है। ऑप्टिकल हो रहा है
एग्जैक्टली फ्री स्पेस ऑप्टिक्स, दैट इज फ्री स्पेस ऑप्टिक्स।
उसमें अगर वायर लगा हुआ है तो 2500 प्रोवाइड
वायर नहीं लगा हुआ, अगर अगर तो वायर लगा हुआ है तो वो तो फिर अपने कैंपस में जितना वायर लंबी है उतना
बच्चों से यही पूछा तो कहता नहीं सर कि नॉलेज तक है
उन्हें उनको फिर लिटिल नॉलेज।
मुझे नॉलेज नहीं था उसका,
अच्छा,
इसलिए मैंने पूछा। फोटो दिखाई तो
वो एफएसओ बेस्ड, एफएसओ फ्री स्पेस ऑप्टिक्स कर रहे हैं इस पे काम सारे स्टार्टअप से मिलके, बढ़िया हो रहा है, करते हैं डिस्कस।
फोन किया था मैंने वो एक बच्चे की मैरिज के लिए।
अच्छा आपने किया था,
मैंने
ओके
किया
ओके ओके ओके। एक्चुअली सर उधर भी
कुछ पता नहीं चला।
मतलब दे डोंट एंटरटेन पर्सनल थिंग्स वहाँ पे।
Hello.
So let us try to create a simulation setup. Let me Started? Already started. So everyone, if you can focus for some few minutes. Okay. Uh, so as per the topic, wavelength division multiplexing, or either DWDM, whatever like you want to enhance. So I have performed WDM application here with three scenarios: utilizing free space optics channel, utilizing optical fiber, also utilizing ground to UAV, UAV to UAV, and UAV to ground. So recently there is no such highlights regarding WDM application with respect to UAV methodology. But in case you are interested, you can explore this and you can publish as many as papers you want. Very simple, fundamental. So here, a transmitter, let me explain you. Uh, those who are new to this concept. So here we have taken four transmitters. These are optical transmitters: 1, 2, 3, and 4. These are the four optical transmitters. Now, how we have compiled this? Let us see. So this is a carrier CW laser. You can either choose it as a frequency in terahertz, or you can choose it as a wavelength in nm. Depends upon you, or even hertz also. So whatever the units you want, you can use. If it is in nm, let us say if it is in an nm, then 193.1 terahertz is equal to 1552.52 nm. That is approximate. So this is a carrier, this is a modulator, and this is the data we are binding, or you can say we are modulating it with the carrier. So what this data is, these are the pseudo random bit sequence generators, means it will randomly generate zeros and ones, or otherwise in case you have your own bit pattern in the form of zeros and ones, you can choose user defined bit sequence generator. In case you want to define your own bit pattern, you can choose bit sequence generator, user defined bit sequence generator. So this is in the form of bits, that is zeros and ones, binary signal. So you can assume that in case you have audio, video, images, whatever the data you have, you can encrypt it in the form of zeros and ones, that is into binary. Then the binary data is fed into electrical generator. So electrical generator will get the binary digits from this generator. It will convert it to the electrical signal. If you double click on the output port, you can see this is the electrical signal. And this electrical signal is further fed into Mach-Zehnder modulator. So here the Mach-Zehnder modulator takes the input from this NRZ pulse generator in the electrical form, and another one is through carrier, that is optical signal. So both the arms will be fed with the respective signals, and in turn we are ready with our final output at Mach-Zehnder modulator, that is optical signal. So this is optical signal. So in this way, these are the 4 transmitters, but here the variation is as per the principle of WDM, wavelength division multiplexing. It means we are varying the wavelength or frequency. So at the first transmitter we are utilizing 193.1 terahertz. In the second one we are using 193.2, third 193.3, and fourth 193.4 terahertz. So in respect to your application, you can design multiple channels, 2, 4, 8, 16, 32, 64, and so on. So it depends upon the application you want. Accordingly, you can create the number of channels. So now, after getting the optical signal from all the transmitters with varied frequency or wavelength, we are muxing it using WDM muxer. So this is 4x1, and you need to mention the channel frequency with respect to the signal you are receiving. Like for the first one it is 193.1, and up to 4 it is 193.4. Then we are using a medium, that is universal FSO channel. So here the universal FSO channel range I am using is for 200 meters. So you can optimize this, you can increase the range depending upon the actual result you are getting. And I am utilizing the FSO weather parameters for clear, haze, and fog environment. And depending upon the visibility, you can change this visibility as per your application. So here it is open-ended, clear environment, 50 kilometers of visibility. And if you feel that it is a fog, you can mention 50 meters, 100 meters, like whatever the scenario you want to create. And if you want to mention it for rain or snow, so you can choose precipitation. And for precipitation, you need to mention the precipitation rate depending upon the rain or cloud, or the snow. And if it is clouds, then you need to choose the type of clouds. So we have a list of clouds here. Depending upon the height or the altitude from the ground, you can choose the clouds for the environment. So right now I am choosing a clear environment with a visibility of 50 kilometers and radius is 1000 nm. I am not choosing any scintillation here because I am not like rigorously doing research here. This is just for the sample. So this is universal FSO channel, and after passing it through this, we are again demultiplexing it. So this WDM demuxer will help you to split your frequencies into separate channels, and after splitting you are receiving it on a respective pin photodiode or avalanche photodiode or any receiver you have. And after receiving it on a pin photodiode, we will be filtering it using low pass Bessel filter. And at last we are doing analysis of quality factor, your eye diagram height or its eye opening, and we are also checking out for OSNR and SNR, means signal to noise ratio and optical signal to noise ratio. See, in optical communication or in these kind of applications, when you are analyzing something, a few of your factors or comparisons preferably will help you to enhance your publication. For example, BER, quality factor, your amplitude histogram, and your OSNR, your SNR, your power factors, means what you are feeding it as an input, and at the end, at the output, what power you are getting. So these kind of parameters or terminologies can help you to maintain its graphical representation, means whatever you are doing, you can show it graphically. So here, after simulation, what I found is, as an example, for the first transmitter, this is the RF radio frequency we are transmitting. So this is power with respect to frequency. This is basically generated by your NRZ generator after getting the random bits. So the bits can be anything. You can feed your own bits. For example, if you are working with some another simulator and your output is in the form of bits, you can choose that bits and you can feed it here. That can also be utilized in this case. And the spectrum analyzer, when you bind everything, when you mux everything, so here at optical spectrum analyzer, you are getting 4 various wavelengths or frequencies, you can say. So this is the output of optical spectrum analyzer. In case if you have the same in your lab, you can do some R&D and you can see how the visual effects are there with your OSA. And at a single channel, I am looking for another spectrum. So this is the main channel frequency we are getting here. Also, we are getting some harmonics, leftover harmonics here in relation to other channels. And if I look into the analysis, so here I have 73 Q factor, minimum bit error rate 0, eye height threshold decision. So we have these results at one channel, similarly for another channel, then third channel, and then fourth channel. So we have successfully compiled a WDM based concept using free space optics channel, where we are utilizing 4 channel system, in which we are using 4 channels for our various applications, binding it together, transmitting it through a free space medium, receiving it at a ground, and again distributing it to our subscribers. And sorry, yes, I am using NRZ technique. Yes, we can change, we can choose RZ also, but as per, yeah, you're right, as per actual research, RZ is better than NRZ. Exactly, right. So you can compare these methodologies. You can design using RZ, NRZ, and other application factors as well. And then at the last, you can compare. This can also be a research paper. Anybody? Okay, so this was utilizing FSO. What if I use optical fiber? Generic single mode fiber, SMF, and in India we are utilizing SMF21. That is a patent of Corning Inc. USA. Corning Inc. is a company in USA who manufactures optical fibers, and of course they are the main developers of Gorilla Glass. So the Gorilla Glass is in our screen of the phones or LEDs. So that are basically patented or manufactured or invented by Corning USA, and SMF21, which is being copied in India for fabricating optical fibers. Like they have taken the reference from SMF21 Corning. So this optical fiber is SMF21, and you can change the properties of this optical fiber as per your application. So this is here, it is generic 1550 nm, 50 kilometers of length. You can change the length of the fiber. Attenuation type you can change, like either it is constant or it depends upon your own logic. In case you have your own file, you can customize it. Attenuation you can change. Generic way it is 0.2 dB per kilometer, and if you feel that you have your own fiber from some another company and on their data sheet it is mentioned 0.4 or 0.1, so you can mention it here as per the data sheet of actual fiber manufacturer. Then dispersion coefficient like GVDs and all, group velocity dispersion, third order dispersion, then beta 2, beta 3. So these all are the parameters related to fiber development. So depending upon your requirement, you can change. So similarly, all other properties can be changed, but here I am taking it by default. So after simulating, utilizing this 50 kilometers of optical fiber, again, here now you see the BER, it is average. So you can fine tune the BER, and quality factor is good because as per IEEE it should be 6 or more than that, right? So you can improve this, you can fine tune this, because here I am using 50 kilometers of range. If I use 1 kilometers of optical fiber, definitely the BER will be 0. I am sure it will be nearby. Exactly. This is only a mathematical equation, you can say. So here what I want to explain is you can choose optical fiber as well for the same application, that is WDM. And similarly, what if I choose UAV? I don't think there is much publications in relation to this WDM utilizing UAV. So here what I have tried to do is, after muxing, I have processed my data from ground to UAV, means from ground to UAV. So this is my UAV, ground to UAV, and this range is 1 kilometer. And this is what I'm trying to do here. You can do this. You can do this. You can transmit this optical signal from one UAV to another UAV, to multiple UAVs, and then to ground.
Even now, there is a free for that one state and another. So these as a concept, yeah, it is possible.
Let me check. I don't think so. Recently, we have played with the beam waist, transmitter height, and altitude discretization steps, then scintillation. In case you have like working model, or if you want to work on that model, we can collaborate. We will add this with your name. We will do that. So here you can change the dynamics of UAV, like transmitter jitter or receiver jitter, its angular tilt, Then beam wanderer means it all depends upon beam. For a proper PAT system, you should be very focused upon the beams. So you can play around with the beam profiling of the communication. So I request you to explore the evaluation version of latest version so that you can read regarding the datasheet of this UAV. So actually it was implemented through NRC, that is National Research Council of Canada. So that is a government entity of Canada, and they have funded this project, and we have successfully completed this, and after the completion we have made a model of this UAV and introduced it in Opti system. So here, coming back to this section, so ground to UAV, then UAV to another UAV, and then again from that UAV to ground. So I am basically transmitting 4 various wavelengths, combining it through MUX, transmitting it again through UAV, then another UAV, and then again back to that ground station, and then again splitting that. So here again I have successfully analyzed it for the better results. Maximum Q factor 226, BER 0, eye height threshold, and for second channel again it is approximately same. For the third channel again the clear eye, and for this one also again the clear eye. So it means that this system is successfully deployed, and the range is from ground to UAV 1 kilometer and then to another 1 kilometer. So for 2 kilometers of flying UAVs, we have successfully implemented WDM application. So you can also work on this. WDM using FSO, there are a lot of papers, but WDM using UAV, you can search for that. And even you can multiply this, means from one UAV to multiple UAVs, or from ground station to multiple UAVs. Again, that will be like a tree communication for WDM concept. Any question? Because this is a kind of a concept which is hybrid basically. FSO is fine, but what if your free space optics channel, that is UAV, whatever it is, like drone, balloon, or whatever it is. So if it is not stationary, if it is flying, you have to take care of beam profile to manage for proper pointing, acquisition and tracking, and all the parameters will be taken into account so that it will help you to analyze the eye opening at the receiver part, the power taken for that. Definitely for longer ranges, you have to maximize the power. Here it is 1 milliwatt. 0 dBm is equal to 1 milliwatt. So you can maximize the power in case you want to increase the range. But there will be like more noise. You have to suppress that, you have to filter that. So once you start doing some project or writing, like start writing a paper, you will find a lot of equations. So definitely, I think in case you want to publish that, you can add a lot of things in this. Any question? Anybody? Sir? See, let me tell you, this is for the iteration part. For example, if I design erbium doped fiber amplifier, in order to activate your erbium doped fiber amplifier, for example, of 5 meters of a length, you need to mention the iteration starting from 10 and to 20 for the global parameters. Let me tell you. So for the global parameters, so it depends upon application to application. For example, if I double click here, if I set the iteration to 20, means your runtime will go for 20 iterations, and at the end you will have a signal index profiling, which is like I am explaining right now. So again, if I simulate this one, so it is still working because the iterations are 20. Done. So accordingly, at some point you will get some better result. So this is the reason we choose signal index. Good question. Anybody? So now the final conclusion for this application is you can use wavelength division multiplexing or dense wavelength division multiplexing or any kind of application utilizing this concept, and you can choose your own channel depending upon how you want to make it complex or you want to compare it, and in case you want to compare it, definitely you would like to publish it. So I request you to evaluate it and do your publications. Now I'm again moving to PPT, or should I stop? I have a lot of data to share, but anyways, thank you so much.
Insightful and engaging session. I would like to request Professor Surjit Balara sir to please present the token of appreciation to Amardeep sir. Please do the honor, sir. I would also like to request Surjit sir to please present the token of appreciation to Mr. Varun Pandey, sir. Thank you, sir, for being with us. So now with this, we are concluding day 5 session. I would like to request all participants to please come forward for a group photograph. Thank you. With this, we conclude day 5 session of FDP. Thank you everyone for being with us. और ये बेटे संभाल के रखिए, कल के इसको लगेंगे अपने कल के मैम का सेशन है ना प्रिंसिपल सर की आने ये संभाल तो सेटअप कितने सर तो प्रवीण के हाथ में प्रवीण को बोले कल चाहिए सेटअप और कल के लिए तो नीचे लग कल के नीचे कल की दोबारा